episode. All right, now let's look at this question we are asked for today. The question reads: how many moles of copper would be deposited by passing 1 Faraday of electricity through copper chloride solution? How many moles of electricity, how many moles of copper will be deposited when we pass 1 Faraday of electricity to a particular salt, and the salt is copper chloride? Now, let's analyze that question very quickly. This is a formula for copper chloride, right? Copper 2 chloride, CuCl2. Now, if you notice, if you ionize copper chloride, we are going to get Cu2 plus and Cl minus. Now, this is what we are going to get. This simply tells us that copper is a divalent what metal, right? Copper is a divalent metal. Divalent simply means when a particular metal have two oxidation number or plus oxidation number, it is called a divalent metal. But if you have just one oxidation number, it's called a monovalent metal. 3, it is called a trivalent metal, right? So copper here is a divalent metal. Now remember the laws of electrolysis. It states that 1 mole of a monovalent metal, 1 mole gives us one mole is equal to 1 Faraday for a monovalent metal. Now, if it's a divalent metal, 1 mole of that particular metal will give us 2 Faradays. If it's a trivalent metal, 1 mole is equal to 3 Faradays of that particular trivalent metal. But in this case, the equation we are faced is copper, and we said copper is a divalent metal because when you ionize the solution of a compound that copper is present in, you're going to have 2 plus, right? Meaning it's a divalent metal. Now let's go back to the question. The question says how many mole of copper will be deposited when we have the divalent metal here. You add an electron, the copper metal will be deposited here. But in this case, in order to balance up the equation, we have 2 here. So you simply say that 1 mole of the copper, look at 1 mole of the copper, we need 2 electrons, also known as 2 Faradays. In terms of quantity of electricity, it is 96500, the Faraday's constant. So 1 mole of copper here is equal to 2 Faradays or 2 electrons, or 96500 times 2, right? So we mean the same thing. So if it is a divalent metal, 1 mole of this particular copper is equal to 2 Faradays. But the question now says, in that question I just said, the question says, how many mole, let's say X mole, how many mole of that same copper will give us 1 Faradays? When we use 1 Faradays, how many mole of the copper will be deposited? Very easy. Now let's solve for X. Now, in order for us to solve for X, we are going to do 1 times 1 divided by 2. Very easy. 1 times 1 divided by 2. And that simply gives us 0.5 mole. So in essence, if 1 mole of copper, we need 2 Faradays to deposit 1 mole of copper. Definitely, we need 1 Faraday to deposit 0.5 mole of copper. As easy as that. If you enjoy watching this video, make sure you drop a comment, share to your friends, subscribe to this page, and bye for now. Have a nice day.